way. The portfolio expected return is just the weighted average of the individual securities expected return. So early on, we calculate the expected return of stock A and stock B. And for stock A, the expected return is 3.2%. And there's a 50% of the weight of the portfolio is on stock A. So weight that expected return of stock A by its weight, 50% times 3.2%. Now, the rest of the portfolio is on stock B, which has an expected return, negative 1.5%. Weight that by the stock B's weight, which is 50%. So the weighted average of these two stocks' expected return is 0.85%. And that is the portfolio's expected return, which is the weighted average of the individual securities' expected return. Another way to calculate the portfolio expected return, well, we have to look at that table. In the table, we have 5 possible economic states: recession, slowdown, flat, mild growth, and the booming economy. The probability of these 5 possible economic states. And then stock A's possible outcome, stock B's possible outcome in these different economic states. Now, the portfolio has 50% of the weight on stock A and 50% of the weight on stock B. In the economic recession, what is the portfolio's possible outcome? Well, 50% of the portfolio is on A, and A's return in the recession is negative 30. 50% of the weight is on B, and in the recession, B's return is positive 20%. So the weighted average of these two stocks' return in a recession is 50% times negative 30% plus 50% times positive 20%. That should give us about negative 5%. Multiply the portfolio's possible outcome by the probability of that possible outcome. So the first possible outcome for the portfolio is negative 5% multiplied by 10% probability. So we have negative 0.005. And we do the same for the economy in the slowdown, and then flat economy, mild growth economy, and the booming economy. And we calculate the portfolio's possible outcome. So 0 in the slowing down economy, 1.5% in the flat economy, 0 in the mild growing economy, and 7.5% in the booming economy. Multiply these possible outcomes of the portfolio by the probability. And then we sum up all the product of the probability and the possible outcome of the portfolio. That should give us 0.85%, which is exactly the same result as we did early on. So once we calculate the portfolio's expected return, following the same way we calculate the standard deviation of the individual stocks, we can calculate the standard deviation of the portfolio. So here we have 5 possible outcomes of the portfolio, and then these possible outcomes of the portfolio subtract the expected return on mean of the portfolio, which is 0.0085. And then the difference of the possible outcome and the expected return of the portfolio, take the square term of that and then multiply by the probability. So we will have the variance of the portfolio, which is 0.00083025. Take the square root of the variance, we have the standard deviation of this portfolio, which is 0.028814,059. And this portfolio standard deviation, similar to the individual stocks standard deviation, is a measure that stands for the overall risk of the individual stocks or the overall risk of the portfolio. So the variance of this portfolio is 0.083%. The standard deviation is 2.881%. Now, the portfolio expected return, as we have observed, is the weighted average of the individual components' expected return. So the portfolio's standard deviation is not the weighted average of the individual components' standard deviation, because on the previous slide, we calculated the portfolio standard deviation. That's 2.881%. Now, stock A's standard deviation is 18.407%. Stock B's standard deviation is 12.855%. Now, the weight on these two stocks is 50-50, so the weighted average of these two standard deviation is 15.631%. And the portfolio's standard deviation, as we calculated on the previous slide, is 2.881%, which is much lower than the weighted average of stock A's standard deviation and stock B's standard deviation. And that weighted average is 15.631%. So we can get this conclusion: a portfolio's expected return is the weighted average of the individual securities' expected return. However, a portfolio's standard deviation, which stands for the overall risk of the portfolio, can be much lower than the individual securities' standard deviations weighted average. And what makes this happen? Well, recall the two companies or two stocks, what they do in the good economy and the bad economy. We know stock A moves along with the economy, stock B moves against the economy. So we can say stock A and stock B are negatively correlated, right? When stock A is doing well, stock B is not. And when stock B is doing well, stock A is not. So the negative correlation between stock A's return and stock B's return, that makes this possible, that the portfolio's standard deviation is much lower than the weighted average securities standard deviation. So the negative correlation between these two stocks' return, that actually reduce the portfolio risk. Mathematically, we can also calculate the portfolio standard deviation another way. So first, let's calculate the variance of a portfolio. The portfolio's variance equals stock A's weight multiplied by stock A's standard deviation, and take the square of these two terms. Stock B's weight times stock B's standard deviation and the square term of this product, and then plus 2 times stock A's weight times stock B's weight times the covariance between stock A and stock B. And if we take the square term of the variance, we get the standard deviation of the portfolio. So the standard deviation of the portfolio is the square root of stock A's weight times stock A's standard deviation, the square term of that, plus stock B's weight times stock B's standard deviation, the square term of that, plus 2 times weight on A, weight on B, covariance between A and B. Now, here in statistics, The covariance measures a co-movement between two variables. However, the covariance is not standardized, so it only measures the direction of the co-movement, but not the degree of the co-movement. So to standardize the covariance by dividing the covariance by the product of stock A standard deviation and stock B standard deviation, we can get the correlation coefficient between stock A and stock B. And the correlation coefficient between two variables measure both the direction and the degree of the co-movement between these two variables. So in this case, mathematically, covariance can also be written as the product of standard deviation of A times standard deviation of B times the correlation coefficient between A and B. Now, the correlation coefficient, because it's the standardized covariance, it takes only a range of values. The range is between -1 to +1. So the minimum that the correlation coefficient is -1. The maximum of the correlation coefficient can be +1, and any value between -1 and +1. Now, when the correlation coefficient is +1, what does that mean? That means these two stocks, A and B, will be perfectly positively correlated. So if the correlation coefficient between A and B is +1, that means stock A, stock B are perfectly positively correlated. Well, what exactly does that mean? Well, that means whenever A does anything, B does exactly the same thing. So basically, these are exactly the same stock. But anyway, so if the correlation coefficient is +1, then we can simplify the portfolio standard deviations calculation to the weighted average of stock A's standard deviation and stock B's standard deviation. So this is how it's simplified. It's algebra. So in the equation, portfolio standard deviation is the square root of the following terms. Weight of A multiplied by standard deviation of A, the square term of that product. Weight of B multiplied by standard deviation of B, the square term of that. And then 2 times weight of A, weight of B, standard deviation of A, standard deviation of B, then multiplied by the correlation coefficient between A and B, which is +1 in this case. So anything multiplied by +1 is that itself. So the third term is 2 times weight of A, weight of B, standard deviation of A, standard deviation of B. So that can be simplified to weight of A times standard deviation of A plus weight of B times standard deviation of B, and then the square term of this weighted average. So the square term cancels out with the square root. We have the portfolio standard deviation equals the weighted average between A standard deviation and B standard deviation. Now, this is a special case when correlation coefficient between A and B is +1, which means stock A, stock B perfectly positively correlated. They're actually the same stock. Now, in this case, the portfolio standard deviation of the portfolio's overall risk is the weighted average of stock A's standard deviation and stock B's standard deviation. So what does that mean? Well, in plain English, that means if you have two stocks, A and B, which are positively, perfectly correlated, or you have the same stock in your portfolio, then you have the worst diversification because the correlation coefficient is +1. Your portfolio's risk or standard deviation is just the weighted average of the individual security standard deviation. In this case, it's the weighted average of standard deviation of A and standard deviation of 2. And this is the worst type of diversification you can have because you have exactly the same stock in the portfolio, but this does not add any risk, although it doesn't reduce any risk. For any other value of correlation coefficient, as long as the rho value is less than 1, it can be negative. That means stock A, stock B are not perfectly correlated. In this case, the portfolio standard deviation will be less than the weighted average of the individual securities standard deviation. So for two stocks, as long as they're not perfectly positively correlated, they can even be positively correlated, but as long as the correlation is not positive 1, then your portfolio's risk measured by the standard deviation of the portfolio will be less than the weighted average of the individual stocks standard deviation. So in this case, your portfolio's risk is reduced by having these two stocks in the portfolio. So graphically, let's see what happens when you have two stocks are perfectly positively correlated, or the correlation coefficient is positive 1. So you have stock A, and the other one does exactly what A does at any time. So let's call it stock A prime. Now, by combining these two stocks together as a portfolio, well, you have a portfolio which is just the mirror image of stock A or stock A prime. Well, let's see, this portfolio's risk is exactly the same as either stock A or stock A prime. So, well, the portfolio does not increase any risk, and it didn't reduce any risk neither. If you have two stocks that the correlation coefficient is negative 1, so we say these two stocks are perfectly negatively correlated, and here graphically you have stock M and you have stock W. Stock M is the blue dotted line and stock W is the red dotted line. And you can see whenever M does something, W does exactly the opposite. So that's why we say these two stocks are perfectly negatively correlated. Now, by combining these two stocks in one portfolio, actually the portfolio becomes the green line in the graph, which means either the stock M or stock W, if we look at them individually, they have their risk in terms of the standard deviation. Now, by combining these two together, actually we eliminate the risk of that portfolio, because all that portfolio does is a straight line as the green line shows. So it always gave you a return of 15% in this case. There's no volatility, there's no risk that the portfolio has. Now, for any other correlation coefficient value, for example, if the correlation coefficient is positive 0.35, then what happens when we construct a portfolio? Well, individually, let's say we have two stocks, W and Y. W is the red dotted line and Y is the blue dotted line. Now, by combining these two together, we have a portfolio, the green solid line, WM. Well, looks like WM, although it has some risk, but the risk is much lower than the individual stocks risk in terms of the standard deviation. So you can see the distribution of the green line is much narrower than the distribution of the W or M. So what does that mean? Even the correlation coefficient is positive, as long as it's not perfectly correlated, the portfolio can still reduce some risk. Creating a portfolio, we begin with one stocks, and then let's say we add randomly selected stocks into our portfolio. What would that do to our portfolio's risk? Well, if we only have one stock in our portfolio, well, we don't know what that stock is, but on average, a stock's standard deviation is around 35%. So if we just have one stock in a portfolio, then that portfolio's standard deviation or that portfolio's risk is about 35%. And then let's say we randomly selected some stock into the portfolio. Well, how do we randomly select a stock? Well, suppose we can put all the stock's name on a wall, and let's blindfold somebody and ask this person to throw a dart at the wall. And then whenever that dart hit, let's say it will hit a stock's name. So that's called a randomly selected stock. Okay? And in reality, most of the stocks are positively correlated with the market. So in reality, most of the stocks are positively correlated with each other. However, they're not perfectly positively correlated with each other. So by combining stocks, as long as they're randomly selected into the portfolio, generally it will reduce the portfolio's risk in terms of its standard deviation. Okay? However, the standard deviation can only be reduced to a certain level, and beyond that level, we cannot reduce that standard deviation of the portfolio anymore.